In the summer of 1940, as Nazi tanks crushed everything in their path across Europe, a phone rang in Detroit. On the line was William Knudsen, former president of General Motors, now working for the federal government to prepare America for war. He was calling K.T. Keller, the president of Chrysler Corporation, with an urgent question. Could Chrysler build tanks for the United States Army? The answer he received was stunning in its honesty. I do not know. I have never seen one of these things. And yet, within months, that same man would oversee the construction of the largest tank factory the world had ever seen. Within years, his company would produce more tanks than the entire Third Reich. His name was Kaufmann Thuma Keller, though nobody ever called him that. Everyone simply called him KT. And this machinist from Pennsylvania was about to transform American industry into the arsenal that would win the Second World War. This is the story of how a farm boy who never earned an engineering degree produced Hitler's war machine, invented solutions that scientists declared impossible, built weapons he had never imagined, and then quietly returned to making automobiles as if nothing extraordinary had happened. It is a story of ingenuity, determination, and the remarkable power of American manufacturing when challenged to achieve the impossible. It is the story of how Detroit built the tanks that rolled all the way to Berlin. In the spring of 1940, the world watched in horror as Europe collapsed. Hitler's Blitzkrieg, a devastating combination of tanks, aircraft, and mobile infantry, shattered Poland in just 5 weeks. Denmark surrendered in 6 hours. Norway fell in 2 months. The Netherlands collapsed in just 5 days. Belgium lasted 18. And France, the great power that had held the line for 4 brutal years in the previous war, the nation that possessed the largest army in Western Europe, fell in only 6 weeks. The British Expeditionary Force barely escaped annihilation at Dunkirk, rescued by an armada of small boats, but forced to abandon almost all of their heavy equipment on the beaches. By the end of June, Nazi Germany controlled virtually all of Western Europe from the Arctic Circle to the Pyrenees. Britain stood alone, battered by relentless bombing during the Battle of Britain, waiting for an invasion that seemed inevitable. Winston Churchill warned his people to prepare for their finest hour. But privately, he knew that without American help, Britain could not survive indefinitely. Against this backdrop of catastrophe, the United States found itself dangerously unprepared for modern warfare. The American military had withered during the long years of peace and economic depression. The Army ranked 17th in the world in terms of size and capability, smaller than the armies of Portugal, Romania, or the Netherlands. American soldiers trained with broomsticks because there were not enough rifles. They practiced maneuvers with trucks that had the word tank painted on their canvas covers because actual tanks barely existed. The nation that would soon become the arsenal of democracy possessed fewer than 400 tanks, most of them obsolete designs left over from the previous war, completely outclassed by the German panzers that were dominating Europe. President Franklin Roosevelt understood that American involvement in the conflict was becoming unavoidable. Even if the nation managed to stay out of the fighting, it would need to arm itself and supply its allies. On December 29, 1940, Roosevelt would deliver his famous Arsenal of Democracy speech, calling upon American industry to produce the weapons needed to defeat fascism. But months before that speech, he had already begun laying the groundwork for military mobilization. In late May of 1940, Roosevelt asked one of the most capable production men in America to come to Washington and help prepare the country for war. William Cygnus Knudsen was a Danish immigrant who had arrived in America in 1900 with $20 in his pocket and barely any English. He had worked in shipyards and railroad shops before joining a company that manufactured parts for the growing automobile industry. When Ford Motor Company acquired that firm, Knudsen rose rapidly through the ranks, eventually supervising the establishment of Ford assembly plants throughout the United States. After a falling out with Henry Ford, Knudsen moved to General Motors, where he transformed the struggling Chevrolet division into the best-selling automobile brand in America. His rallying cry to Chevrolet dealers became legendary. He promised them 1-for-1 against Ford, meaning Chevrolet would match Ford's sale for sale. In his thick Danish accent, it came out as "Vun for Vun," and the phrase became a battle cry that eventually led Chevrolet to surpass Ford in sales. By 1937, Knudsen had become president of General Motors, leading the largest corporation in the world. Now Roosevelt needed him to perform an even greater miracle. He needed Knudsen to transform American industry from peacetime production to military manufacturing at a scale never before attempted in human history. Knudsen gave up his position at General Motors, accepting instead a salary of $1 per year, and went to work as Commissioner of Industrial Production for the National Defense Advisory Commission. One of Knudsen's first and most pressing challenges was finding someone to build tanks. The Army needed them desperately, but no American company had ever mass-produced tanks before. The few tanks that existed had been built slowly, almost by hand, in government arsenals using methods more suited to the 19th century than the 20th. Knudsen needed someone who understood how to build complex machines quickly and in enormous quantities. He needed someone who knew mass production. He needed the automobile industry. On June 7, 1940, less than a week after Knudsen arrived in Washington, he placed a telephone call to Detroit. On the other end of the line was K.T. Keller, the president of Chrysler Corporation. Knudsen asked a simple question. Could Chrysler build tanks for the United States Army? Keller's response would become legendary in the annals of American industry. "I do not know," he said with characteristic honesty. "I have never seen one of these things." But his next words revealed everything about his character and the spirit that would drive American industrial mobilization. "We would certainly like to try." Those 7 words changed history. Do you think business leaders today would take on challenges completely outside their expertise the way Keller did? Let me know your thoughts in the comments. Kaufman Thuma Keller was not born into privilege or wealth. He came into the world on November 27, 1885, on a small farm near the village of Mount Joy in Lancaster County, Pennsylvania. The area was rural, agricultural, a place where families worked the land, and success was measured in hard work rather than formal education. Young Kaufman grew up washing wagons, currying horses, and learning the rhythms of farm life. Money was always scarce. Opportunity seemed impossibly distant for a boy from such humble circumstances. But even as a child, Keller possessed something that could not be purchased at any price. He had an extraordinary gift for understanding how machines worked. While other boys might glance at a piece of equipment and see only metal and moving parts, young Kaufman saw the logic behind the design, the principles that made it function, the ways it might be improved. This intuitive mechanical intelligence would define his entire life. Keller graduated from Mount Joy High School at the age of 16, younger than most of his classmates. He managed to scrape together enough money to attend Wade Business College in Lancaster, where he studied bookkeeping, shorthand, typewriting, and commercial law. It was practical education designed to prepare young men for careers as clerks and office workers, but Keller had larger ambitions. At 18, he found work as a secretary to a traveling lecturer and accompanied the man across the Atlantic to Britain. For 2 years, the young Pennsylvanian experienced the wider world, gaining perspective that would serve him throughout his career. When he returned to America, he was ready to begin building his future. Keller landed a job as a clerk at the Westinghouse Machine Company in East Pittsburgh. It was steady work with a respectable company, exactly the kind of position his business college education had prepared him for. But clerical work frustrated him deeply. He wanted to build things, to work with his hands, to understand the machines themselves rather than simply shuffling papers about them. He made a decision that revealed his character perfectly. He asked for a transfer to the machine shop and accepted a significant pay cut to get it. Most young men would have stayed with the safe, better-paying clerical position. Keller chose to start over, learning a trade from the ground up. For the next several years, Keller learned the machinist's craft in the most thorough way possible by doing the work himself. He ran lathes and drill presses. He learned to read blueprints and work to precise tolerances. He discovered that he had an instinct for mechanical problems, an ability to look at a machine and understand not just how it worked, but how it could be made to work better. By the time he left Westinghouse, he had risen to assistant superintendent of the department that manufactured automobile engines for the Chalmers Detroit Motor Company. In 1910, at the age of 24, Keller made the move that would shape the rest of his life. He relocated to Detroit, drawn by the explosive growth of the automobile industry. The motor car was transforming American life, and Detroit was the epicenter of that transformation. Every ambitious young engineer and mechanic in the country wanted to be there, and Keller was determined to make his mark. He worked for several small automotive companies, gaining experience and building his reputation. Then he caught the attention of Walter Chrysler, who was at that time transforming the Buick division of General Motors into a powerhouse of engineering and production excellence. Chrysler recognized a kindred spirit in Keller, another man who had worked his way up from the shop floor, who understood machines not from textbooks, but from getting his hands dirty. Chrysler brought Keller to Buick as general master mechanic. When Walter Chrysler left General Motors in the early 1920s to found his own company, Keller stayed behind for a time, continuing to rise through the ranks. He became vice president of Chevrolet, in charge of manufacturing, a position of enormous responsibility in the largest automobile company in the world. But in 1926, Walter Chrysler called again. He needed someone to manage the manufacturing operations of his rapidly growing corporation, and there was only one man he trusted completely for the job. Keller accepted the offer and never looked back. He joined Chrysler Corporation as vice president in charge of manufacturing and quickly demonstrated the same practical brilliance that had marked his entire career. Under his direction, Chrysler's manufacturing operations became models of efficiency, producing high-quality vehicles at competitive prices. By 1935, K.T. Keller had become president of Chrysler Corporation. Under his leadership, the company pioneered engineering advances that became standard throughout the automobile industry, including high-compression engines and four-wheel hydraulic brakes. Sales exceeded $1 billion per year. Chrysler became the second-largest automobile manufacturer in the world, trailing only General Motors. And Keller ran it all with the same hands-on approach he had learned as a young machinist in Pittsburgh decades earlier. He regularly visited factories and spoke directly with workers on the production line. When asked about his background and expertise, he would say simply, "I am a machinist by trade." It was not false modesty. It was the fundamental truth about how he saw himself and his work. This was the man who answered William Knudson's telephone call on June 7, 1940. This was the man who admitted he had never seen a tank, but was willing to try building them anyway. This was the man who would transform American industrial might into the arsenal that would crush Nazi Germany. The day after Keller agreed to take on the assignment, he assembled a team of his best engineers and manufacturing specialists. They faced an immediate and fundamental problem. They were supposed to build tanks, but none of them had ever actually seen one up close. How could they manufacture something they did not understand? Keller contacted Knudsen and asked a practical question. Where could his people actually look at a tank? Knudsen arranged for the Chrysler team to visit the Rock Island Arsenal in Illinois, where the Army was developing a new medium tank design designated the M3. When the engineers arrived at Rock Island, they found a prototype without its armor plating, essentially a mechanical skeleton that allowed them to examine the internal workings of the vehicle. They studied every component carefully, asked questions of the Army engineers, and took detailed notes on everything they observed. They requested copies of the blueprints so they could study the design back in Detroit. Unfortunately, only a few extra sheets were available at the facility, nowhere near enough to understand the complete vehicle. The Chrysler team took what they could get and returned to Detroit with their incomplete documentation and a head full of questions. On Monday, June 17th, 1940, the full set of blueprints arrived by special courier. The package was enormous, weighing 186 pounds. That night, Keller gathered a select group of his most trusted engineers and manufacturing experts on the bare top floor of the Dodge Division plant on Conant Avenue. They worked in absolute secrecy, spreading the massive blueprints across every available surface, poring over drawings that described a machine unlike anything they had ever built. These men knew how to make cars and trucks. A tank was something entirely different. It was a rolling fortress of steel and firepower, vastly more complex than any civilian vehicle. The armor alone weighed tons. The main gun required precision mechanisms to aim and fire. The tracks and suspension systems had to support enormous weight while crossing rough terrain. The engine had to deliver power far beyond anything required by an automobile. Every component had to be stronger, more durable, more precisely manufactured than its civilian counterpart. To grasp the true scale of what they were undertaking, Keller ordered a full-size wooden mock-up to be constructed. Every piece was to be shellacked after cutting, because shellac scratches easily. Any scratches during assembly would reveal where parts did not fit together properly, where more engineering work was needed before actual production could begin. Within a single week, the Chrysler team had analyzed the complete set of blueprints, estimated manufacturing costs, identified potential problems, and developed a preliminary production plan. They calculated that they could build the M3 tank for $33,500 per unit, a price that included not just the tank itself, but also the construction of an entirely new factory to produce it. The Army accepted the proposal, and Chrysler formally committed to building tanks for the United States military. But where would they build them? The existing Chrysler plants were already running at capacity producing automobiles for the civilian market. Building tanks would require an entirely new facility, purpose-built for the unique demands of armored vehicle production. Keller proposed constructing the largest tank factory in the world on 113 acres of farmland in Warren Township, about 17 miles north of downtown Detroit. The government would own the facility, but Chrysler would design it, build it, and operate it. On August 15, 1940, authorization came through to construct a $20 million tank arsenal. Ground was broken in September. The factory would be enormous, stretching 5 city blocks long and 2 blocks wide. The main assembly building alone would cover more than 1,250,000 square feet of floor space. The walls were designed 3 feet thick, massive reinforced concrete capable of withstanding aerial bombardment should enemy aircraft ever reach American soil. The famous industrial architect Albert Kahn designed the structure with characteristic foresight. He created a dual-purpose facility, one that could produce armaments during wartime and be converted to peaceful civilian production afterward. It was a practical recognition that the war would eventually end, and the factory would need to serve the nation in peacetime as well. Winter came early to Michigan in 1940, but construction never stopped. Workers poured concrete in freezing temperatures. They erected steel frameworks through snow and ice. The schedule was impossibly aggressive by any normal standard. The Army needed tanks immediately, and Keller intended to deliver them regardless of weather, obstacles, or conventional wisdom about how long such a project should take. Here is where the story becomes almost unbelievable. Before the factory walls were even completed, before the roof was fully installed, before the building could properly be called a building, Chrysler began producing tanks. Engineers brought in a steam locomotive and parked it inside the unfinished structure, using its boiler to generate heat so workers could operate through the brutal Michigan winter. Snow drifted through gaps in the incomplete walls. Wind howled through open sections of the roof. Ice formed on exposed metal surfaces, and on the production line below, ignoring all of these conditions, the first M3 tanks slowly took shape. The workers who assembled those early tanks performed miracles of improvisation and determination. They worked in conditions that would be considered intolerable in any normal factory, bundled in heavy clothing against the cold, their breath visible in the frigid air. But they kept working because the nation needed what they were building. On April 24, 1941, just 7 months after construction began, the Detroit Arsenal delivered its first completed M3 tank to the United States Army. The ceremony was broadcast nationwide by radio, letting the American people know that their country was finally beginning to arm itself for the conflict that seemed increasingly inevitable. Dignitaries and military officers gathered to watch the 30-ton steel monster demonstrate its capabilities. The tank fired its guns and crashed through obstacles while newsreel cameras recorded every moment for theater audiences across the country. Governor Murray Van Wagoner of Michigan attended the ceremony, along with military brass and Chrysler executives. K.T. Keller watched with quiet satisfaction as the machine his company had built proved itself capable of everything the Army required. It was a triumph of American manufacturing, a promise of what was to come. Do you think modern companies could match this speed of execution, building a factory and delivering a complex product in just 7 months? I would love to hear your perspective in the comments. The M3 tank that rolled off the line that April day was a remarkable machine for its time, even if it had significant limitations. It carried a 75mm main gun capable of penetrating most enemy armor, along with a 37mm gun in a rotating turret and several machine guns for defense against infantry. The tank weighed approximately 30 tons and could travel at speeds up to 26 miles per hour on roads. But the M3 was fundamentally a compromised design, rushed into production to meet urgent needs. Its most significant flaw was the mounting of the main gun. The 75mm weapon was positioned in a sponson on the right side of the hull rather than in the rotating turret. This meant the entire tank had to be turned to aim the main gun, severely limiting its effectiveness in fluid combat situations. The design also gave the tank an unusually high profile, making it an easier target for enemy gunners. The rotating turret carried only the smaller 37mm gun, which was increasingly inadequate against modern armor. British troops fighting in North Africa, who received the M3 under Lend-Lease, called it the Grant when fitted with a British-designed turret. They appreciated its firepower and reliability, but had no illusions about its tactical limitations. Some called it a brave but imperfect weapon. Others used less polite terms, but they also acknowledged that it was better than nothing, and in the desperate days of 1942, better than nothing was often the best available option. American planners knew even before the M3 entered production that they needed something better. A new design was already taking shape on the drawing boards, one that would address the M3's most critical shortcomings. This would become the M4 Sherman, the most famous and widely produced American tank of the entire war. The Sherman mounted its 75mm main gun in a fully rotating turret, eliminating the most significant tactical weakness of the M3. The hull was lower, presenting a smaller target to enemy gunners. The suspension and powertrain were refined for better reliability and easier maintenance. The design emphasized the qualities that American manufacturing did best: standardization, interchangeability of parts, and ease of mass production. In the summer of 1942, the Army asked Keller if Chrysler could produce 750 Sherman tanks per month. It was an astronomical number, far beyond anything ever attempted in armored vehicle production. Keller agreed immediately, even though his engineers had not yet seen the final designs for the new tank. It was becoming a pattern in American industrial mobilization. The government would ask if a company could do something that seemed impossible, and the answer would be yes first, with the details figured out afterward. The transition from M3 to M4 production presented enormous engineering and manufacturing challenges. The Sherman was a significantly different vehicle from its predecessor, requiring new tooling, new jigs and fixtures, new manufacturing processes, and extensive retraining for the workforce. A conventional approach would have shut down the production line for weeks or even months to make the changeover. Keller refused to accept any production interruption. His solution was audacious. The Detroit arsenal would switch from building one tank to building an entirely different tank without ever stopping the production line. On August 3, 1942, the last M3 tank rolled off the assembly line at the Detroit Arsenal. It was number 3,352. Immediately behind it, without a single day of lost production, came the first M4 Sherman. The changeover was executed seamlessly, a manufacturing feat that amazed military observers from around the world. No other nation could have accomplished such a transition with such efficiency. But even as the Shermans began flowing out of the Detroit arsenal, Keller faced another crisis that threatened to shut down tank production entirely. The M3 had been powered by a Continental radial aircraft engine, a reliable and powerful motor that served the tank admirably. But aircraft production was expanding exponentially as America built up its air forces, and every available radial engine was desperately needed for planes. The Army informed Chrysler that the aircraft engines would no longer be available for tanks. Keller needed to find a replacement power plant, and he needed to find it immediately. His engineers proposed a solution that was one of the most unusual power plants ever created for any vehicle. They would take 5 standard Chrysler automobile engines, 6-cylinder flatheads that had been powering passenger cars for years, and combine them into a single monstrous power unit. The engines would be arranged in a star pattern around a central crankcase, their individual crankshafts connected by a complex gear train to a single output shaft that would drive the tank. The result was designated the A57 Multibank. It combined 30 cylinders across 5 engine blocks into a 21-litre behemoth that produced 425 horsepower and over 1,000 pound-feet of torque. The engine looked like something from a fever dream, a Frankenstein monster bolted together from automobile parts. Engineers from other companies thought Chrysler had lost their minds, but the multibank worked. It worked remarkably well. The engine proved reliable and powerful, capable of pushing a Sherman tank across almost any terrain. Because it was constructed entirely from components that were already in mass production for civilian vehicles, Chrysler could manufacture the engines quickly and cheaply without developing new tooling or production processes. Spare parts were readily available. Mechanics who had worked on Chrysler cars could understand and service the unusual engine with relatively little additional training. Most remarkably, the multibank's modular design provided an unexpected advantage in combat. If enemy fire damaged some of the engine's cylinders, the tank could continue operating on the remaining power units. Chrysler's engineers claimed the tank could still move with 12 of its 30 cylinders knocked out. Some reports suggested it could limp along with only 2 of the 5 engine banks still functioning. In the chaos of combat, where a disabled tank often meant death for its crew, this redundancy could mean the difference between survival and destruction. The A-57 multibank engine was so large that the Sherman tank had to be lengthened by several inches to accommodate it. Vehicles equipped with the multibank were designated M4 MAW, and were primarily supplied to British and Commonwealth forces through the Lend-Lease program. Chrysler dispatched technical representatives to England to train British mechanics on the unusual power plant. The training paid off. British forces used M4A4 Shermans extensively throughout the war, including many that were converted into the famous Firefly tank destroyers, armed with powerful 17-pounder guns capable of defeating German heavy armor. Between July 1942 and November 1943, Chrysler manufactured nearly 10,000 A-57 multibank engines. Of these, approximately 7,500 were installed in new tanks, with the remainder held as replacement engines for vehicles in the field. It was a testament to American ingenuity, the ability to solve impossible problems by combining existing resources in novel ways. But tanks were only part of what Keller and Chrysler contributed to the war effort. As the conflict expanded, the government kept coming with new requests, each one seemingly more impossible than the last. Could Chrysler build Bofor's anti-aircraft guns, the Swedish-designed weapons that were desperately needed to protect ships and installations from air attack? Yes. Could they manufacture aircraft engine components to feed the insatiable demand for warplanes? Yes. Could they produce radar assemblies, the secret technology that was proving decisive in the Battle of the Atlantic? Yes. Could they design and build marine engines for landing craft and patrol boats? Yes. Not once did K.T. Keller turn down a request from the government. Not once did his engineers fail to deliver what was asked of them. The Chrysler Corporation became synonymous with reliability and can-do spirit, a company that would take on any challenge and find a way to succeed. Then, in the spring of 1943, came a visitor with the most unusual and consequential request of all. Colonel Edgar Garbish of the Army Corps of Engineers, who happened to be a former West Point football star and son-in-law of the late Walter Chrysler, telephoned K.T. Keller on March 20th on behalf of an organization called the Manhattan District. Keller had never heard of it. Almost no one outside the most secret circles of the government had heard of it. But Garbish said the matter was of the highest importance, and he arranged for a group of visitors to meet with Chrysler's leadership on April 2nd at the company's headquarters in Detroit. The delegation that arrived was led by a heavyset brigadier general named Leslie Groves. Accompanying him were several other officers and civilian scientists. What Groves told the assembled Chrysler executives sounded like something from a science fiction novel. The United States government was attempting to build an atomic bomb, a weapon of almost unimaginable destructive power, based on principles of nuclear physics that most laymen could barely comprehend. The project, code-named Manhattan, was consuming billions of dollars and employing tens of thousands of people across multiple secret facilities. But there was a critical bottleneck that threatened to delay or even derail the entire effort. To build an atomic bomb, scientists needed enriched uranium, a specific form of the element that was extremely rare in nature. Natural uranium was almost entirely composed of the isotope uranium-238, which was useless for weapons. The fissile isotope uranium-235 made up less than 1% of natural uranium. Separating these isotopes was extraordinarily difficult because they were chemically identical, differing only in atomic weight. At a massive facility being constructed near Oak Ridge, Tennessee, a plant called K25 would use a process called gaseous diffusion to enrich uranium. The raw material would be converted to a corrosive gas called uranium hexafluoride, which would be forced through thousands of stages of porous barriers. At each stage, the slightly lighter uranium-235 molecules would pass through the barriers marginally faster than their heavier uranium-238 counterparts. After passing through hundreds or thousands of stages, the resulting gas would contain enough concentrated uranium-235 to fuel a weapon. The process required thousands of large cylindrical metal containers called diffusers, tanks that would hold the uranium hexafluoride gas under high pressure. These diffusers had to be absolutely airtight. They had to be manufactured to tolerances tighter than almost anything in normal industrial production. And most critically, they had to resist the horrifically corrosive effects of uranium hexafluoride, which would eat through most metals. The only material known to resist uranium hexafluoride was nickel, but building the diffusers from solid nickel was simply impossible. It would require the entire American nickel supply for years, perhaps decades. There was not enough nickel in the world to complete the project using solid metal construction. General Groves asked if Chrysler could find a solution. Keller listened carefully, then consulted with his engineering staff. Among them was a plating specialist named Carl Huesner, who had spent years developing and perfecting electroplating processes for Chrysler's automobile components. Huesner believed that nickel-plated steel could work just as well as solid nickel for the diffusers, using only a tiny fraction of the precious metal. Instead of building diffusers from solid nickel, they would build them from ordinary steel and apply a thin but perfectly uniform coating of nickel to every interior surface. The scientists at Columbia University, who had developed the gaseous diffusion process, were deeply skeptical. They had already spent $100,000 trying to make electroplating work and had failed completely. The plating process they had attempted produced coatings full of microscopic pinholes that would allow the uranium hexafluoride to reach the underlying steel and cause catastrophic corrosion. The scientists insisted that large-scale electroplating simply could not be done. Keller told Huesner to try anyway. It was the same response he had given when asked to build tanks he had never seen. Do not tell me something is impossible until you have actually tried it. Within 2 months, Carl Huesner developed an electroplating process that worked. The key was absolute cleanliness and precise control of every variable in the plating bath. Huesner built special facilities to demonstrate the technique, plating a large piece of boilerplate with a thin sheet of nickel and subjecting it to conditions even more corrosive than it would face in actual K25 operation. The plating held perfectly. There were no pinholes. There was no corrosion. The scientists who had declared the process impossible were forced to admit they had been wrong. Chrysler received a $75 million contract to produce the diffusers for K25. The company designated the effort Project X100, a deliberately meaningless name that would reveal nothing about the actual work being performed. Chrysler established secret offices at 1525 Woodward Avenue in downtown Detroit, an abandoned department store building where FBI agents patrolled the premises around the clock. The windows were covered to prevent any observation from outside. Workers entering the facility were sworn to secrecy and subjected to thorough background investigations. The actual manufacturing of the diffusers took place at Chrysler's Lynch Road factory on the city's east side. The entire facility was converted to this single purpose, with special air conditioning and air filtration systems installed to prevent any contamination of the nickel plating. The work required extraordinary precision. Each diffuser contained end pieces with millions of tiny holes that had to be drilled to exact specifications. The nickel plating had to be absolutely uniform across enormous surface areas, without a single pinhole or imperfection that might allow the corrosive uranium hexafluoride to reach the underlying steel. Thousands of workers labored on components whose ultimate purpose they were never told. Security was absolute. The workers knew only that they were building something important for the war effort. They had no idea they were helping to create the most destructive weapon in human history. The manufacturing process that Keller described was remarkably straightforward in concept, even if fiendishly difficult in execution. Take the raw cylinders, machine them to precise dimensions, plate them with nickel, install the internal heads and barrier tubes, seal everything tight, weld it together, and test every completed unit for leaks. Any diffuser that failed testing was rejected and rebuilt. The standards were unforgiving because the consequences of failure were too severe to contemplate. By the end of the war, Chrysler had shipped more than 3,500 completed diffusers to Oak Ridge, filling 1,000 railroad cars with components for the atomic bomb project. The nickel plating that scientists had declared impossible worked flawlessly. Not a single diffuser failed due to corrosion. The units operated at K25 until the 1980s, more than 4 decades after they were built. They helped produce the enriched uranium for Little Boy, the atomic bomb that destroyed Hiroshima on August 6, 1945, and helped bring the Pacific War to an end. General Leslie Groves later wrote a secret letter to Keller expressing gratitude that could never be made public. No one outside the K25 portion of the project, Groves wrote, can ever know how much we depended on you and how well you performed. Those of us who do know will never forget how important your work was and how well you did it. The atomic bombs ended World War II and ushered in the nuclear age. They were the product of brilliant scientists and massive government investment. But they would not have been possible without a plating specialist in Detroit who refused to accept that something could not be done, and an executive who told him to try anyway. Back at the Detroit arsenal, production continued at a pace that astonished everyone who witnessed it. The factory operated around the clock, 3 shifts per day, 7 days per week, with no holidays and no breaks in the relentless flow of tanks. In December of 1942, the workforce achieved what seemed like an impossible record by producing 896 Sherman tanks in a single month. That translated to roughly 30 tanks every day, approximately 1 completed tank rolling off the production line every 45 minutes. The scale of the operation was almost beyond comprehension. The Detroit arsenal consumed steel by the thousands of tons. It required enormous quantities of aluminum, copper, rubber, glass, and dozens of other materials. The electrical power consumption rivaled that of a small city. Railroad trains arrived constantly, bringing raw materials in and carrying finished tanks out. The rumble of tank engines being tested echoed across Warren Township and could be heard for miles in every direction. The workforce grew to more than 5,000 men and women, many of whom had never worked in heavy manufacturing before the war. Housewives, office workers, farmers, and students learned to operate machinery, read blueprints, and assemble complex military equipment. They worked in conditions that would be considered harsh by peacetime standards, but they understood the importance of their labor. Every tank they built would carry American soldiers into battle. Every tank might mean the difference between victory and defeat, between life and death for young men fighting on the other side of the world. And still the requests from Washington kept coming. The Army needed a better tank, something more powerful than the Sherman, something capable of standing up to the heavy German Tigers and Panthers that were decimating Allied armor in the hedgerows of Normandy and the forests of the Ardennes. The result was the M26 Pershing, a heavy tank with a 90mm gun capable of penetrating German armor at long range. The Pershing weighed over 40 tons, significantly heavier than the Sherman, and featured improved armor protection for its crew. Chrysler began producing Pershings at the Detroit Arsenal in early 1945. Adding yet another vehicle to its already overwhelming production portfolio. When Nazi Germany surrendered in May of 1945, the Detroit Arsenal had manufactured 22,234 tanks. That figure represented more than 1/4 of all tanks built in the United States during the entire war. It was more tanks than the entire Third Reich produced during the same period from all of its factories combined. A facility that had not existed 5 years earlier, producing a product its creators had never seen before receiving the assignment, had outproduced the vaunted German war machine. The strategic impact of this production miracle cannot be overstated. American tanks were not individually superior to their German counterparts. The Sherman was outgunned by the Panther in a one-on-one engagement and hopelessly outmatched by the massive Tiger. German tanks were engineering marvels, carefully designed weapons that dominated any battlefield where they appeared. But German engineering excellence was also German engineering weakness. The complex, precision-manufactured tanks took too long to build and were too difficult to maintain and repair. American factories could replace lost tanks faster than Germany could destroy them. For every Sherman knocked out in combat, 3 more rolled off the production lines at the Detroit Arsenal and its sister facilities. The Germans could win individual tank battles, sometimes spectacularly, but they could never win the war of industrial attrition. General Dwight Eisenhower, Supreme Commander of Allied forces in Europe, never forgot the contribution of American industry to final victory. After landing at Normandy on D-Day, he toured the invasion beaches and saw the wreckage of destroyed vehicles scattered across the sand. Broken tanks, shattered trucks, burned-out landing craft littered the shore as far as the eye could see. To most observers, the scene looked like a junkyard of ruined machinery, a testament to the terrible violence of the landings. To Eisenhower, it looked like something else entirely. It was proof that the war was being won, not just by the soldiers fighting on the beaches, but by the workers laboring on assembly lines thousands of miles away. In his memoirs, he later reflected on how deeply the sight of that destroyed equipment impressed upon him the industrial might of America. The wreckage on those landing beaches represented the vast productive capacity that made Allied victory possible. President Franklin Roosevelt had called upon America to become the arsenal of democracy. And K.T. Keller had answered that call more completely than anyone could have imagined. Chrysler produced not just tanks, but anti-aircraft guns, radar assemblies, aircraft engines, marine engines, military trucks, and components for the atomic bomb. The company never turned down a request from the government. It never failed to deliver what was promised. It exemplified everything that American industrial power could achieve when properly directed and motivated. When the war ended in August of 1945, Keller might reasonably have expected recognition commensurate with his contributions. He had mobilized one of America's great industrial enterprises for total war. He had solved problems that experts declared unsolvable. He had helped build the weapons that defeated fascism and ended the deadliest conflict in human history. In 1946, President Harry Truman awarded K.T. Keller the Medal for Merit, the highest civilian honor for contributions to the war effort. It was appropriate recognition, acknowledging all that Keller had accomplished. But characteristically, Keller was not the type to dwell on honors or rest on past achievements. There was still work to be done. The immediate post-war years brought new challenges that demanded his attention. Chrysler had to convert back to civilian production, retooling factories that had been building tanks and military equipment to once again produce automobiles for eager American consumers. It was the reverse of the industrial miracle Keller had performed in 1940 and 1941, and he managed it with the same efficiency and determination. But the peace did not last as long as everyone hoped. On June 25, 1950, North Korean forces invaded South Korea, and America suddenly found itself at war again. The conflict revealed how quickly military readiness had deteriorated in the 5 years since World War II ended. The armed forces needed tanks, planes, and weapons, and they needed them fast. President Harry Truman turned once again to K.T. Keller. The United States was falling behind the Soviet Union in the development of guided missiles, the weapons that would define strategic warfare for the rest of the century. Truman wanted Keller to coordinate and accelerate the American missile program. In October of 1950, Keller became director of the Office of Guided Missiles under the Secretary of Defense. It was a position of enormous responsibility, overseeing all missile research and development for the Army, Navy, and Air Force. The fragmented efforts of the different services needed coordination and direction. Bureaucratic rivalries had to be overcome. Resources had to be allocated effectively. Most importantly, results had to be delivered. Keller brought the same practical, hands-on approach that had served him so well in the automobile and tank industries. He visited test sites personally, watching missiles launch and often fail. He asked pointed questions of engineers and scientists. He cut through bureaucratic obstacles with the same determination he had shown when building the Detroit Arsenal. He demanded results, not excuses. For 3 years, Keller drove the American missile program forward, helping to lay the groundwork for the weapons that would eventually give the United States strategic parity with the Soviet Union. He helped integrate the various service programs into a more coherent national effort. When he stepped down from the position in 1953, the program was on solid footing, pointed toward the eventual development of intercontinental ballistic missiles and the space program that would follow. Keller returned to Chrysler as chairman of the board, a position he held until his retirement in 1956. The company he had guided through the Great Depression and World War II was now one of the largest corporations in the world, a pillar of American industry. He had spent more than 4 decades in the automobile business, rising from machinist to chairman. He had helped arm the United States for 2 major wars. He had contributed to the development of the atomic bomb and the nation's guided missile program. And through it all, he had never lost his fundamental identity as a man who worked with his hands. Those who knew Keller in his later years remembered his unpretentious manner. He was a lifelong cigar smoker and never abandoned the habit. He maintained a machine shop in the basement of his Detroit home, where he tinkered with mechanical problems whenever he had spare time. When anyone asked about his remarkable career, about all that he had accomplished, he would reply simply that he had started as a machinist and never forgot what that taught him. The skills he had learned in the shops of Pittsburgh more than 50 years earlier remained the foundation of everything he achieved. K.T. Keller died on January 21, 1966, at the age of 80. He passed away in London, England, far from the Pennsylvania farm where he had been born and the Detroit factories where he had built his legacy. He left behind achievements that transformed not just one industry, but several. The methods of mass production he helped pioneer at Chrysler influenced manufacturing around the world. The tanks his factories built helped liberate Europe from Nazi tyranny and defeat Imperial Japan. The diffusers his workers crafted contributed to ending the deadliest war in human history. The missile program he directed laid the foundation for America's strategic defenses throughout the Cold War. In 1988, more than 2 decades after his death, the United States Army inducted K.T. Keller into the Ordnance Corps Hall of Fame. It was belated but fitting recognition for a man who had done more than almost anyone to arm America for its greatest challenges. The site of the Detroit Arsenal remains in use today. After World War II ended, the facility continued producing tanks through the Korean conflict and the Cold War that followed. In 1982, Chrysler sold its defense division to General Dynamics, which produced M1 Abrams main battle tanks at the Warren location until 1987. The tank factory eventually closed, but the United States Army retained a portion of the property for continued military use. Today, the site houses the Tank Automotive Research, Development, and Engineering Center, along with the Tank Automotive and Armaments Command. American engineers and soldiers continue working where K.T. Keller's workers once assembled Shermans and Pershings, carrying forward a legacy of innovation and manufacturing excellence that began more than 8 decades ago. The lessons of K.T. Keller's remarkable life extend far beyond military production or industrial history. He demonstrated that expertise in one field can be translated to entirely different challenges when combined with practical intelligence, determination, and the willingness to learn. He showed that honest admission of ignorance is not a weakness, but rather the essential starting point for genuine learning. When asked if he could build tanks, he did not pretend to possess knowledge he lacked. He said simply that he had never seen one of these things, and then he went and looked at one, studied the blueprints, figured out the problems, and found solutions. He proved that American industry, when properly motivated and led, was capable of achievements that seemed utterly impossible by conventional standards. Building a massive factory and delivering complex military products within 7 months, switching production from one tank design to another without stopping the assembly line, creating a 30-cylinder engine from automobile parts, making electroplating work when scientists had proven it could not be done. All of these accomplishments defied expert opinion and conventional wisdom. When the government asked if Chrysler could build tanks, K.T. Keller did not promise what he was not certain he could deliver. He did not exaggerate his capabilities or minimize the challenges. He simply said that he would like to try, and then he dedicated everything he had to making it happen. That willingness to tackle unknown problems, to learn on the job, to find solutions when experts said none existed, defined his entire career from the machine shops of Pittsburgh to the boardroom of Chrysler to the highest levels of national defense planning. It is a quality that seems increasingly rare in an age of narrow specialization and institutional risk aversion. Keller was willing to fail. More importantly, he was determined to succeed. The tanks that rolled out of the Detroit arsenal carried American soldiers across the deserts of North Africa, through the mountains of Italy, into the fields and forests of France and Germany. They fought in the frozen hills of Korea and in conflicts around the world for decades afterward. The designs that Keller's engineers developed evolved over time, becoming the foundation for American armored warfare through the rest of the 20th century and into the 21st. But perhaps the most enduring legacy is the example Keller set for leaders in every field. When his country needed him, he answered without hesitation. When told something was impossible, he tried it anyway. When asked to build weapons he had never seen, he figured out how to do it. And when the job was done, he went back to making cars, as if transforming American industry into the arsenal of democracy was just another day's work. They asked if he could build tanks. He had never seen one. He said he would like to try. And he built more tanks than any nation on earth. That was the lesson of K.T. Keller. That was the lesson of the Detroit arsenal. That was the lesson of American manufacturing in its finest hour. Never say something cannot be done until you have actually tried to do it. Admit what you do not know. Learn fast. Work hard. Get your hands dirty. And when someone asks whether you can accomplish the impossible, tell them you would certainly like to try. Those words, spoken by a Pennsylvania machinist to a Danish-born production genius in the summer of 1940, changed the course of history.